Okay, so this problem comes from homework 1.3. It's exercise 1.93, and there's so much here. I didn't want to copy it over to my sketchbook, so I'm going to flip back and forth. While you're watching this video, you may need to pause it so you can see what I'm pointing at a couple times, because I'm going to flip back and forth. All right, let me read it real quickly. Nanotechnology is the field of building blum, 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 blum. One potential application is the construction of dun, dun, dun. By the way, this is kind of a cool first couple sentences, but it doesn't have to do with the question itself. So I'm going to pass on these sentences. Pretty cool stuff. But I get down to the end and I see, aha, suppose that the cell-like nanocontainers are cubic and have an edge length of 24 nanometers. So let me go back over here, draw a picture of one of these things. Okay? And it's cubic, and it has an edge length of, what was it? Where was it? 24 nanometers. All right, so I'm going to go back over here to Sketchbook. 24 nanometers. Now, you may have seen me in class or in a previous video demonstrate that I get nervous when I'm dealing with units like this that are sort of non-SI units. So oftentimes what I'll do is I'll replace the nano with what the nano means, 24 times 10 to the negative 9 meters. So if I've got something to do, I can end up with a unit that I'm comfortable with, like a cubic meter. All right, so let me go back to the question, or back to here, and I've just interpreted. That's what I'm looking at, is a cube with an edge length of 24 nanometers. Okay, so what's the volume of one nanocontainer? All right, ignore the thickness of the nanocontainer's wall. So the volume, in other words, we're going to assume what's the overall volume the thing takes, and we're going to assume that the wall itself is of negligible thickness. Okay, so let's go here. What's the volume of this? Well, the volume for a cube is simply L cubed. Okay, so I'm going to say volume is L cubed. That is 24, just a second here, clear. 24 cubed gives me 13,824 times 10 to the negative 9 times 3, because that's what that's cubed, cubic meters. Was I supposed to give that in a particular unit? It doesn't say what you, oh, liters. Oops, over here, watch out, liters. Okay, so I'm gonna have to convert that to liters when I'm done. Now, I'm gonna go ahead and say that this is 13,824 times 10 to the minus 27 cubic meters. Okay, I did a conversion in a previous video on cubic meters to liters, but I'm going to do it again here. So let's say 1 cubic meter, and what I did was I said meters to centimeters because I know centimeters to mils. That's the reason I'm doing it like this, and I know mils to liters, and that's going to give me liters, right? So let's come over here and say there's 100 centimeters. Oh, but this has to be cubed. Sorry, that's cubic meters, so I've got to cube it. And this is a 1 to 1, and this is a 1 to 1,000. Okay, so 100 cubed is a million. 1 times 10 to the 6 times 1 times 1 times 1 divided by 1,000 gives me 1,000 liters. You might want to consider pausing the video and doing that again. That'd be great practice. Super powerful to be able to do that. So if I have this many cubic meters, then I need to go cubic meters to liters, and it looks like there's 1,000 liters in a cubic meter. And so this is going to give me, watch this, 13,824 times 10 to the minus 24 liters. And I'm going to bring this decimal point up here, 1, 2, 3, 4. And I'm going to make this like minus 20 then, 1.38. Now, last thing I got to do is I got to come over here and say there's 2 sig figs in that. And that's the only number I put in there. That's the only measurement was 24. So it's 2 cubed. So this is going to have to be 2 sig figs. So this is going to be 1.4 times 10 to the minus 20 liters. Okay, and that's the answer for part A. Hope that helps. I'll do part B here in a second.